So, all right, morning all, and thanks very much for joining the session. So, whether you are an enterprise, using telemetry, for example, for ingesting telemetry data into PostgreSQL, or you are a financial company trying to capture end of the day prices from stocks exchanges all over the world into PostgreSQL engine. So you'll be dealing with terabytes, even petabytes of data. So often you run into the scaling challenges. So the scaling challenge could be at the storage level or could be at the compute level, right? You can scale up to the compute to a particular extent, and you can scale up your storage engine to a particular extent. So the sharding is a mechanism where you look forward to horizontally partition your workload across many PostgreSQL instances, right? So in this session, we're going to look into the sharding approach using Postgres FDW, and we'll also visit various use cases. And we look into what Postgres community has done so far, implementing various features into FDW, foreign data wrapper, bringing it closer to a true sharding solution. So my name is Krishna Sarabu. I'm a senior database specialist SA at AWS. I've been with AWS close to a year and a half now, but prior to AWS, I started off my career as Oracle DBA. Most of my work experience for the past 24 years has been in financial industry. So worked with Thomson Reuters for more than 12 years, then on to Bloomberg. So by the way, my colleague is here, former colleague, I would say. So worked in Bloomberg for around 12 years. And I have done some contributions to Patroni. Patroni is an open source tool for managing high availability for PostgreSQL engine, right? So if you are looking at multi-synchronous standby support, so that feature, basically I added it. And so that's pretty much about me. So without a further ado, let's look into the agenda for today. So this is the agenda, right? So we are going to start with foreign data wrappers in PostgreSQL. So basically the various SQL engine, NoSQL engines, etc. And then we are looking into various use cases. So where you can use this foreign data wrapper to address your day-to-day business use cases. And then we look into Postgres FDW, namely, right? Just for this session focus. And we look into the declarative partitioning and FDW, combining those two, how you can horizontally partition or scale out your workloads, right? And then another one I'm going to touch base is the sharding with, I'm going to take a use case, an example, to shard using Postgres FDW, and we are going to look into various optimizer features that have been added recently, right? How optimizers are able to push down the joins, push down case expressions, push down predicates, etc. Right? And then we look into 14 and 15 features with respect to FDW, and then we look into alternative sharding solutions, right? So, sorry, it looks like this is not working, so I'm going to use my mouse. So here is the history of FDW, right? So it all started with SQL Med, which is a standard specification that was set back in 2003, how PostgreSQL should interact with external data sources, right? So it has two parts. One is data link. So the data link enables basically the specification to enable PostgreSQL to interact the files on the operating system using your database columns typically. And the second part is the wrappers. So the wrapper is an interface where you are interacting with external data sources in this case. So namely, you wanted to interact with Oracle, SQL Server, MySQL, even NoSQL engines like, if you're using Cassandra, for example, or HDFS, so on and so forth, right? And even object stores like S3, etc., right? So, and the second part is, right, with the, the second part, whenever you're installing the Postgres engine, by default, it comes with two foreign data wrappers. One is file FDW, and the second one is Postgres FDW. And file FDW to interact with the files on your file system. Typically, you would use for analyzing your PostgreSQL logs, for example, right? And the popular foreign data wrappers in the community includes Oracle FDW and the TDS for SQL, interacting with SQL Server, MySQL FDW, interacting with MySQL FDW, and then you have Cassandra, FDW, HDFS, and Mongo. So various data stores So Postgres FDW, it is to interact with PostgreSQL databases. You have the DB link capability, right? And you also have FDW capability. So the difference between those two is the transaction semantics, so which we are going to talk about it. And if you are using any managed services like Amazon RDS for PostgreSQL or Amazon Aurora for PostgreSQL compatible database, so you also get log FTW for interacting with PostgreSQL logs. And if you want to analyze, slow queries, for example, you wanted to analyze the connection rate, for example, if you are logging or logs, etc., right? And then Oracle FDW, if you wanted to interact with Oracle, TDS for SQL, MySQL, and Postgres. So these are all the various use cases. First use case typically is the federation. Someone just mentioned actually using for federated queries. I mean, whether you have a regulatory requirement to keep your data local to the compute node or the database node, or you have a requirement where you wanted to keep the older data into object stores like S3 or onto file systems. So you will be using the federated queries in that case, right? And the second use case is the database migrations. So if you are using, I don't know how many of you used Aura Migrator in the past. I have used significantly in my past. So if you are using, they came up with the DB migrator interface now, but underneath it uses Postgres FDW foreign data wrapper. So all it's going to do is it's going to import the schema, and then you can use that interface to ingest the data from Oracle into PostgreSQL. So that's another use case. It could be the migrations. And the third use case I just spoke about is the log analysis. It's extremely useful, right? I mean, from the SQL engine, you want to analyze what's my connection rate over time, right? Or you wanted to analyze, how the locking contents, deadlocks, so on and so forth, right? Or slow queries. It's extremely useful from the SQL interface using log FDW. And another one is the data lifecycle policy, especially when you are dealing with the time series data, or you are dealing with telemetry, for example, right? You're ingesting the statistics from various compute network resources into the database for telemetry, and you wanted to archive the data over time, but sometimes you have the SLA requirements, right? You need to keep the data in low-cost storage engine or object storage, for example, so you can use S3, right? And finally, the sharding. So when you are running into write scaling, read scaling challenges, or the scale, or you have the limited storage capacity and you wanted to scale out beyond the supported limited storage, or you want to scale out your compute beyond the supported compute, right? So the sharding is another approach to horizontally partition your workload across many PostgreSQL instances. So here is an example, and this slide illustrates. I have an orders table, and which has orders P1, P2 partitions residing in PostgreSQL engine, and P3 and P4 partitions going into Oracle, and then P5 going into SQL Server, P6 going into PostgreSQL. So just to illustrate, how much you can push PostgreSQL further. And let's look into PostgreSQL FDW now. PostgreSQL FDW, it's a foreign data wrapper to access data that's stored in external PostgreSQL engines, all right? And it supports the full DML. It supports insert, update, delete, and copy and truncate, of course, the selects, right? And typically, you would use only if you are using inherited tables. I'm not sure how many of you used inherited tables prior to declarative partitioning. But if you are using only on any inherited table, typically it would bypass all the partitions and try to get the data from the parent table. So that's you would use normally. And if you are using this only option on foreign data wrapper table, so it's going to ignore it. So basically, it has no effect on the remote server. And if you are using upsert on conflict do update, if you are using that, that's not supported. But of course, it supports do nothing option. And cross-version compatibility, yes, of course, you can go as far back as to 8.3. So it supports that. But one thing to keep in mind when you're using cross-version, right? So whenever you are using foreign data wrapper, FDW underneath will reset your search path to PG catalog. So that thing, it's very important to keep in mind when you're writing your code. So always prefix your schema names when you're referring to objects using FDW. And the second thing to keep in mind is if you write immutable function, and if you're using that immutable function in where class, so FDW safely assumes that I can push this immutable function to the remote server. So when it is pushing, and if that function doesn't exist on the remote server, naturally you would get function doesn't exist error. So these are all the things you need to keep in mind interacting with external stores. And finally, the transaction management, which is a key factor in any distributed environment. So I have a few slides put in, and I'm going to talk about that in detail, how the ACID compliance works when I'm interacting with distributed data stores. So especially atomicity, and another one is the consistency. So how do I get the consistency across distributed databases? And how do we get atomic commits across distributed databases, all right? So this is a slide at very high level. You have all the features. I try to document as much as I can. Few I ignored because I couldn't fit in, but I try to highlight the very important ones. So we can go one by one. So all these features have been done over the time, bringing your FDW closer to a true sharding solution in open source engine. So the first thing you need is join pushdown capability. It all started with that. So if I'm joining table A and table B, and both are foreign tables residing on same foreign server. So does my optimizer has the ability to push down? Yes, so that's the feature. So it was able to push down, it's able to push down the join to remote foreign server. And the second one is, of course, the sort push down. So it is if I'm using order by, so Postgres added the feature back in 9.6, so where it was able to push down order by to remote foreign server. And the fetch size is very important, right? If you're writing an application code, naturally you're looking at the fetch size, right? How many iterations I'm going back and forth between my database and client, and every time I'm extracting the data, how many rows I can fetch in one single fetch operation. Push down is like ability to, let me put it this way. The ability to take this partial work and push it to the remote server and execute that partial work and get the data. So let's say if I'm doing select sum of from so-and-so table, and table is foreign table. So optimizer has two approaches, right? One, extract entire data here and then perform the sum aggregation, or push this sum aggregation to the remote foreign server and then perform the aggregation on the remote and get only the result. So naturally, it improves the performance.
So when you push down the optimizer used for running the query is used on the remote server, not the
local server, that's correct. So I have a few slides that it gives you the execution plan and highlights each and every operation, right? And the fetch size is very, very important. So that talks about how many rows it can fetch in one single, how many rows it can extract in one single fetch. And PG10, aggregate push down. So any aggregate functions, max, min, sum, so it has the ability to push down. And the joins push down is very, very important. If I am joining two foreign tables, so extract the data, join it locally versus pushing the join to the remote, perform the join and get the data. So so that improves performance significantly. And the sort push down, so this is, they added few additional cases from 9.6 in order by push down. And version 11, again, aggregate push down with few additional cases, especially if the foreign table is partitioned, right? So that's one. And the partition-wise join is very, very important. Those who are from Oracle background, they know how important it is, right? Especially dealing with the analytics data. And if I have two tables partitioned in the same mechanism and using same partition boundaries, and when I'm joining these two tables, so what optimizer would do is it's going to join these partitions individually, right? And that greatly improves the performance if you add parallelism to partition-wise join, right? And PG11 implemented the feature and also added the ability to push down the partition-wise join to foreign server. And the other one is the DML pushdown in inserts updates. And PG12, order by limit pushdown capability. Again, few more cases for that. PG13 is advanced partition-wise joins, so yeah, this is important. So in the previous one, what I mentioned was the table has to be partitioned the same way with the same partition boundaries. So PG13, on the other hand, if the partition boundaries do not match, it has the ability to perform partition-wise join and ability to push down to remote server. And PG13 is again another very improvement. A very good feature was parallel foreign scans. So it has the ability to perform asynchronous foreign scans parallelly. So that's a great improvement from performance point of view. And PG15, case expressions. If you are using case expressions in your select statement, it has the ability to push down case expressions. And parallel commit is another one. So far, what it was doing is, whenever you begin a transaction in local server, so naturally, it's going to open a transaction on every remote server, right? Not every, but any remote servers, you change the data. So it's going to spin off a transaction. When you commit, it's committing sequentially. So that's adding up to the latency to your local commits. So it has the ability to now parallelly commit on all remote servers. So the features we just discussed, I'm going to just highlight few features here on 14 and 15. And the support for bulk inserts, the batch size is very, very important. So if you are inserting your data in a bulk, your FDW now supports it, but it depends on a few things, right? So if the table is very wide, so the number of rows, typically you would push it in a batch, depends on the number of attributes or number of columns in a table, and times the number of tuples you are trying to batch. So if it exceeds 64K, it automatically adjusts it for you. It's not going to fail. It scales down, adjusts the batch size for you underneath. And asynchronous concurrent execution capability, it's very, very important. I just mentioned, and I have a slide. So whenever you performing any queries on partitioned foreign tables, so it has the ability to perform asynchronous parallel execution on each foreign node. And another one was the connection management. See, what happens is, when I'm dealing with the distributed data stores, it's very important you have the right connection management is included, right? So every time, so there is a parameter that was already called keep connections, and what it does is, it enables FDW immediately upon the transaction completion, should I keep the connection or not? That's all it's going to influence. So my advice to you is, if you are dealing with that, always think of a database proxy. So if you are using on-premise self-managing PostgreSQL, PG Bouncer is an example you could implement in between. And if you are using managed services like RDS, PostgreSQL, or Amazon Aurora, managed RDS proxy is another solution. So which can do connection management for you, and it can multiplex and scale out your connections to database workloads. And another one was automatic reconnection foreign servers. So far, until 13, what was happening was, until this feature was implemented, every time you restart a foreign server, and let's say your local node has an open connection, and your foreign node got restarted, and when you try to run a query, it used to give you an error. So this feature basically re-established the connection for you underneath, and making this failovers or restarts transparent to your application, right? And support for truncate on remote tables also is a new feature. And 15 is, we just talked about parallel commits and case expression pushdown, right? So with that, few things I would like to highlight from performance point of view, or query optimization point of view, before we jump onto the execution plans. So fetch size, we talked about, that influences how many rows it should fetch in one single. If does it open a cursor on the remote database?
It's open a cursor in the remote DB. The barrel will not work. If it's a barrel if the option is enabled, the barrel is not supported with cursors. So
yes.
With
with one. Thank you for.
No,
No, you're absolutely right. I have actually, I can show you. It does open the cursor. So I'll talk about it. Thank you. Actually, it's a very good point, Ali, you raised. So if you, by default, the fetch size is 1. Ali raised a very good point. Default fetch size is 1. So when I run a select statement, so the reason is, right, your transaction isolation is going to change. It's very important to keep in mind. So if I use the fetch size, and if you run a select statement, you're not fetching the data, it's using repeatable read isolation at that time. And whenever the statement gets executed, it's going to take the snapshot. You're all familiar with PG current snapshot, right? It's going to take the snapshot, and it's going to give you the consistent view of the data at that point in time, right, at that snapshot. And if you define a fetch size, it's going to declare a cursor. When you declare a cursor, what happens is, when you declare a cursor, it's going to take a snapshot when the cursor was declared. And as you start fetching the data from the cursor, it's going to use that snapshot. So the image you see is going to be different. I have a slide actually highlighting that fact. Thank you, Ali. And yeah, and query, another one, yeah, use remote estimate before I jump on. It's very important. See, the statistics are very, very important when our optimizer generates the execution plan. It knows, that's how it knows the selectivity of your predicate, right? So use remote is a mechanism where you can tell optimizer to perform explain on the remote database whenever my query is run. But the problem with that is it adds up to the cost. So my advice to you is, instead of using this parameter, analyze the table. So even though it is foreign table, right? When you analyze, it's going to run it's going to get the statistics, store the statistics in a local PGStats table, and it's going to use that statistics. The downside of is auto vacuum, you doesn't aware what's the changes going on in your remote table. So you need to have a mechanism periodically gather the statistics and store those statistics locally. And yeah, and the startup cost, FDW startup cost is, talks about the connection, overhead of connection establishment and the cost associated with it, right? That's all. And it's an arbitrary number. And the tuple cost is the number of tuples you are fetching from the remote database, and the cost associated with, the network cost associated with each tuple. So when you are looking at the cost in the execution plan, so basically it computes, these two parameters are added to that, number of tuples you are fetching times the tuple cost plus the startup cost. Okay? And we already talked about query optimization capabilities, the predicate push down, join push down, all the way down to asynchronous parallel execution capability. So with that, let's jump onto the slides and look into a deeper detail, how optimizer does that. So what you're looking at here is a sharded table, right? I took the same order table and have a partition 1, partition 2 resides on shard 1, and it has orders P3, P4, which is sharded to shard 2, and P5, P6 sharded to shard 3, right? So I have 3 distributed instances where I'm using declarative partitioning across. And with the declarative partitioning, as you can see, two partitions on each node to scale out across 3 nodes, right? So one challenge in this case is high availability, right? PostgreSQL, if you are self-managing, that's going to be a very challenging task. So, what you need is, whenever the shard goes down, you need a mechanism automatically fail over the shard. So PostgreSQL does provide a native streaming replication, which you can use underneath. But what you need is a mechanism. So my suggestion is use the Patroni, like tools like Patroni. Patroni is a powerful tool. It has distributed consensus mechanism, so it can use various distributed stores. It supports Zookeeper, Console, etcd, and even you can use a raft algorithm, right, if you don't have distributed. So using Patroni, you can able to manage the high availability underneath for your shard instance. And of course, if you're going to go with managed solutions with RDS, PostgreSQL or Amazon Aurora, it's all taken care for you, all right? So with that, let's go into the next step, the first optimization feature, the asynchronous parallel execution ability, right? So in this case, as you can see, I turned on async capable, all right, at the foreign server. And when I run my execution plan and reading from my orders table, and you can see there is a append node on the top, and you can see the asynchronous foreign scans at every foreign node it is doing. And so this is what I wanted to highlight, right? So the option async capable controls, whether your optimizer should be able to asynchronously execute that foreign node or not. And this is a new feature that's been added recently. Right? You can specify that this at table level or foreign server level, So if you specify foreign server level, naturally any table using that foreign server inherits that property. And if you are setting at the table level, it's going to override your foreign server property. The second one is the joins and predicate pushdown capability. So in this case, I am enabling partition-wise join, and so I have a parent table and I have a child table, FK local, all right? And I'm joining on column A and applying a predicate on column C with my test value, right? And both the tables are partitioned the same way and using same partition boundaries in this case. And if you look at the execution plan carefully, right? I have the asynchronous foreign execution scan because I already turned on at foreign server level, but look at the remote SQL, right? If I'm paying attention for that foreign scan at the remote select, and as you can see, the inner join is being pushed to foreign server, and then you have the predicate also being pushed to the foreign server node. So that's the beauty of a predicate pushdown feature. And the next one is aggregate pushdown capability. So let's take this further. And if you apply aggregate function on top of it, right, sum, min, max, any aggregate functions. And as you can see here, I have enabled a parameter, enable partition-wise aggregate. And then, so basically what the parameter does is, even on the local node, right, what partition does is, it's going to push down your aggregate function to the partition level and performs the partial aggregation at the partition level, then pass it to the append node to perform final aggregation, right? So in this case, I'm using a foreign server node, so it is pushing down the min, max, and sum, and group by all the way down to the foreign server node. And the next one is order by and pushdown capability. So what I noticed is even, I was testing everything in 15 beta 3, by the way. So it looks like Postgres even 15 beta 3 has very limited capability in this case. I'll show you. So here, what I'm doing here is I'm running the explain plan on asset table, and I'm using the order by, and I'm just interested in the top asset with the highest value, right? Not value, highest value. So if you look at the sort class that was pushed, the sort class was pushed, but there was no limit applied on remote SQL, if you notice, right? So it's fetching all the data, then it's applying the limit 1. When I use the partitioned, when I use the declarative partitioning with FDW, but what if I run directly against the foreign server node? So in this case, if I run against the foreign table directly, you can see that limit 1 is being pushed to the foreign node. So it has a limited capability when it comes to the limit class. And so 15 added case when we talked about it. So this talked about if I'm using case when, you can see that it's pushing that case when expression all the way down to foreign server node, right? So with that query optimization, so let's look into the transaction semantics in FDW. It's very, very important how the transaction semantics works in FDW, right? So this is about two-phase commit. Whenever you are dealing with the distributed databases, what you need is a two-phase commit mechanism. So that's one of the challenge in PostgreSQL. What happens is whenever a transaction begins on a local node, and whenever it touches the remote tuples, right? Your DML, whenever it is dirtying the remote tuples or remote buffers, so it automatically starts the remote transactions underneath for you. The same thing applies with the save point. If you are using a save point, so it creates a save point at the remote tables, remote servers as well. And when you commit the local transaction, it's going to go and commit the transaction on all remote nodes. And if you're committing the save, and if you're rolling back a save point, the same thing gets done on every node, right? So the problem with that approach is, let's say you should a commit, and the commit applied on, let's say, if I take this example, commit applied on shard 1 and shard 2, for example, and before it's applying to shard 3, let's say your shard 3 crashed or failed over. So you have a partial commit in your distributed system, and shard 3 that never made it to the shard 3. So that's the problem right now needs to be solved, right? So if I were to take the two-phase commit. I mean, there are multiple solutions that are suggested, and it's still work in progress. So if I were to take the two-phase commit, approach, so there is a prepare commit. How many? A prepare transaction. I don't know how many of you are familiar with that. So if you are designing from application point of view, if I am designing a distributed system where application is aware of it, so there are open source solutions which I'm going to talk about. If I am designing that, so application connects to Shard1 because it is aware of that this particular work exists in Shard1, makes a change, connects to Shard2, makes a change, and then it runs a prepare transaction on Shard1 and Shard2. Prepare transaction is a mechanism to make your transaction durable on the database node. Right? So if the database node crashes and recovers, so you have the durable transaction stored on the disk. So you can use PG prepare transaction view to look after the transaction, and then you can take an action. So commit prepare transaction or rollback prepare transaction. You just need to know what happened with the parent transaction. So these tools have the mechanism, open source tools, how it can keep track, right? So this animation talks about it, how can use prepare transaction. So let's say I inserted a tuple into orders table that's going into partition 3. So naturally, it will end up landing in Shard2. And let's say I'm inserting one more tuple into partition 5 that's going to go into Shard3, right? And now, if you commit, as I explained, that's the problem, right? When you commit, so the proposal was it's going to send prepare commit to all the shards, that made that opened the transaction, and prepare commit, as I said, it's going to make your transaction durable to the disk, right? And then it's going to issue once it gets the acknowledgement back, then it's going to issue the commit, right? Naturally, once you get the acknowledgement back, it's going to go back to the end user that issued the commit. But the problem is in this case, let's say, even though I'm making the durable, what happens if my Shard3 crashes before it commits the transaction, right? So what you need is a global transaction manager on top of it, which can keep track of your the prepared transaction status. Was it committed it locally or not? If it is committed, so then all it has to do is the minute your shard comes back online, it's going to look into the PG prepared transactions, and based on the status, either it's going to commit prepared or rollback prepared. Right? So what you need is a global transaction manager to handle the two-phase commits and automatically recovering these failed prepared transactions.
Can I ask a question?
Yep.
Let's take the same example, but suppose that Shard1 sent a commit message to Shard2, but then Shard1 failed, and Shard3 never received this commit message. How is it going to
Shard3 never received the commit.
It received prepared statement, prepared request, but never commit.
Yeah, so basically, right, in this case, actually, very good question. So the question is, I have Shard1 which sent a prepared transaction, and it crashed before it received acknowledgement from Shard3, right? That was the question.
No, the question is like Shard1, which is, I think, a transaction coordinator in this example, right?
Mm-hmm.
It sent the prepare message to both Shard2 and Shard3, both acknowledged, and right now it goes forward to the second message, commit. Commit was successfully delivered to Shard2, but then Shard1 failed. It never delivered commit to the Shard3.
Shard3, yeah.
So like we are getting into this inconsistent state.
Thank you. So the global transaction manager, it's beyond the Shard1, right? It's keeping track of the transaction status across all the shards. So prepare the minute, because the prepared transaction already acknowledged, means the prepared transaction is durable on Shard1, Shard2, and Shard3 at this point. And your Shard1 is crashed. It sent a commit, but it did not commit on Shard1 and Shard3, but Shard2 is committed. So the global transaction manager knows that this prepared transaction is committed. It's just that never made it to Shard1 and Shard3. So the minute they recover, it's going to look into PG prepared transactions on both the shards and apply the pending work, commit prepared.
And this global transaction
Yeah, it's a proposal, actually. It's not there yet. It's a proposal. So this is an idea to implement to address this problem. At the moment, the way your FDW works is simply it's going to treat that as a local transaction. So for any reason it fails, you're going to lose the work at the moment, right? And actually, if you look at Citus solved that problem, actually. Citus does two-phase commit underneath, and it does the global transaction management as well. Galera cluster. Yeah, for MySQL, right? Yes, yes. I'm not familiar, but yeah. Citus I was using, so yeah, thank you. Okay, the next challenge is, right, the consistency with the distributed databases. So this is, before we go into consistency, what I wanted to talk about is MVCC, right? You know, you've been hearing this MVCC for so long time. I'm going to take 1 minute to touch base before I go into distributed consistency. So the way consistency works, right, in MVCC is multi-version concurrency control. So that means underneath, it's keeping multiple versions of your tuples underneath. That's all that means, right? And why am I keeping multiple versions? It is for providing read consistency for your queries, right? And so in this case, on the left-hand side, I have a session that started at the transaction ending with 6440. And on the right-hand side, I have a transaction different session ending at 6441, right? So you begin the transaction, you inserted a tuple. On the right-hand side, I begin and I declared a cursor, right? And then I am fetching from the cursor. You get 0 rows naturally. When I declare the cursor, it takes a snapshot of your database, like a PG current snapshot. So it's going to use that snapshot to identify which tuple version should I be returning for this query, right? And then I'm running a select statement. So the select statement at the execution time is going to take a snapshot and use that snapshot to get the data, right? So that also return the 0 rows naturally, right? You know, I'm using read committed transaction isolation level in single instance, right? And naturally, it's going to return you only the committed rows. And I commit on the left-hand side, and I go back to the right-hand side. I run a select statement, returns 1 row, and I try to fetch from my cursor, get 0 rows. I think I already gave the clue, right? So as I explained, the snapshot was taken when the cursor was declared. So when I try to fetch from this cursor, what you're seeing is the data that look like as it at this point in time. So whenever you use that fetch size, that's what it is going to do underneath on the remote foreign node. To keep in mind, it is going to use that read committed isolation, but the snapshot was, sorry, not read committed. So for foreign nodes, it always use repeatable read, but at the time the cursor was declared. And so going into little further, so every transaction ID, and it's a 4-byte integer, so that will give you 2.1 billion roughly, the transaction before it goes into wraparound, right? And you have the xmin, xmax, very important, right? If you go to previous slide, you know, I even circled xmin and xmax. So,
if you connect after the commit, if that transaction was opened before this transaction opened, right, then it should not keep this row.
yeah, there is a select, absolutely. So there is a select statement prior to the commit which I am running, and it's not 0 rows returned there.
So, say if this 6441, if it was 6439.
Oh, yes, yes, that's correct. If your PG current snapshot, looking at the tuples at 6439, for example, it wouldn't see the rows at all even. Yeah, if the select statement was at that snapshot, right? So the way it handles underneath is, it's going to use xmin and xmax, right? Very important. So the transaction max is the tuple that updated or deleted a row, and it also uses xmax. Okay, let me go to the next one. It also uses xmax with multi-exact also. I'm not sure how many of you familiar with the multi-exact. Typically, right, you know, multi-exact is if there is a more than one transaction ID trying to log the tuple. So that's nothing but multi-exact in a nutshell, all right? So when you use select for share, when you use foreign key constraints, underneath it does that for you. So it's multiple transactions locking the same tuple in a shared mode. So it's going to mark the transaction as, that lock as, you know, multi-exact. So in that case also, you see the xmax is being populated, and auto vacuum cleans it up for you later on. And xmin is the one that created the tuple, that inserted the tuple in this case. So whenever you're running a select statement, it's going to take a snapshot, PG current snapshot, and look at, okay, for this snapshot, what version of the tuple I should be returning? Nothing but. So looking at between xmin and xmax, it's going to give you that data. Right? So here on the right-hand side, I was showing you. So for that insert, if you use page inspect and dump the contents, you would see the transaction, you see the xmin ending with 6440 and with xmax 0, which is the current version. And later on, I update the tuple. So when I update, you see two versions of the tuple, right? So when you select from the table with xmin, xmax, pseudo columns, you do see the current version only, as I said. But if I dump my block, you see two versions of the tuple in that block, right? One version ending with the transaction max, xmax marked as the transaction, it's a dead tuple basically, and keeping that tuple for read consistent reasons. So it's very, very important in PostgreSQL. I'm going beyond this sharding, but when you're operating in Postgres, if you have a long-running transactions, long-running queries, it's very important, right? You often see you run the vacuum, your bloating doesn't go away, it doesn't delete the dead tuples. So that's the reason, right? It's keeping these tuples for the read consistency for those long-running transactions. So it's as a best practice, you always use ideal session in transaction parameters, or make sure that you don't run long-running transaction hours or days. Right? And with that MVCC, let's look into the consistency across distributed databases. So here, the transaction, this slide talks about the transaction isolation in FDW. So on the left side, I have a shard one, beginning the transaction, running a count one, all right? And this is a foreign table, by the way. And again, I'm running count one from orders P3. And again, I'm in between on shard two, you made, and I went and deleted 4 rows. I even committed the transaction. So even though I'm running the select statement here on foreign node, what it is doing is, by default, it is using repeatable read transaction isolation, right? So at the transaction begin, it's going to set the snapshot for you, and it's going to use that consistent mechanism to return the data. So the reason is, right, if I'm using a nested loops, for example, right? So when I'm using a nested loops between local and remote, what happens is the left-hand side will be probed first, get the data, and for every tuple returned by left-hand side table, I'm going to probe the remote. I'm going to probe the right-hand side table. And if the right-hand side table happens to be a foreign table, when I'm fetching every tuple, I don't want to see inconsistent images. So for that reasons, even Citus does that too. Citus also uses a repeatable read isolation underneath. So it also supports serialization isolation, but it does not support read committed. Please note, if on a single instance, whenever you are running query, your transaction isolation default is read committed. And when you are dealing with FDW, it's always defaults to repeatable read. Right? And with that, let's look into alternative solutions, right? The first one is application level sharding. So I gave a blog link from AWS. So how you can use this hashing algorithm from your application code, and then you can use database stores like DynamoDB, or even if you're self-managing, you can use Zookeeper console, any storage, right? Distributed consensus store. And then that will give you the object mapping, So for this range of hash values, which shard I should be going to, right? And then you build that logic into your application, and you make your application go towards particular shard. And the blog talks about that in a greater detail. And the second one is if you're using extensions. So Citus, I think version 11, it's fully open source now, all right? And even all the enterprise features like automatic shard rebalancing, so on and so forth, is being open source now. So that's an extension you could use to shard out across. And another one is the sharding spare. I was just talking about it. It's a Java library. And it builds the intelligence for you automatically, and all you do is pass the multiple database stores, it takes care of it for you. So, so these three are alternative solutions, and that brings down to summary. So as I mentioned, right, FDW is a very powerful tool interacting with external stores, solving many business use cases. So whether you want to archive your data to object store, or whether you wanted to shard out, or so, and the main challenging tasks at the moment is the transaction management, especially with the two-phase commit, and the automatic deadlock detection. That's also not there. So if multiple shards involved in a locks that's leading to a deadlock, your FDW would not be able to recognize that at the moment. So these two features currently are lacking. So that brings down to the conclusion. So any questions for me?
Transaction IDs, in your diagram,
You typically coordinator node you would use, but it's you can see the way I designed, the way I put together the slides here. It can go to any of the node, but if it is going to any of the node, the problem is there is a deadlock contention. So that's one thing you need to keep in mind. So if you design your application properly, and application going to a shard, making a change, so that you would never run into any conflict that's leading to a deadlock, then you're good. You can use multiple shards to load balance across or for write scaling. But if you run into a conflict in distributed shards, naturally it has no mechanism to recognize those deadlocks, so application is going to stuck. Or you need some external tooling to identify and terminate or clear the deadlock.
But each row goes to all condition, all field away from it.
No, not each row. So if you look at, right, it's a foreign data wrapper. It's a logical interface pointing to, if I'm like looking at P3, orders P3 on shard 1, for example, it does not have any data locally. So what it has is a FDW pointing to P3 on shard 2. So in this case, it's not a data redundancy. You are distributing the data across multiple Postgres servers.
Whole transaction in this use case is managed by some coordinator, or one of the shard does that manage?
So the transaction management with the FDW right now is whenever you make a change, it's going to treat that as like a local transaction underneath. So whenever you begin a transaction, you make some changes. So it's going to spin off a remote transaction as well, right? And when you commit, it's going to commit locally and remotely. So it's going to treat that. It's not a two-phase commit, true two-phase commit. So PostgreSQL in recent versions introduced two-phase commit with your logical decoding plugins. So if you are using logical, it now supports two-phase, but it's not done yet. It is in Pipeworks actually. There is a patch open already, but it's just not released yet in version 15.
Do you use this solution for Amazon RDS or Aurora?
Can I use this solution with RDS and Aurora?
I'm asking, like, do you use this internally for RDS or Aurora?
Aurora and RDS are, Aurora is a different storage architecture underneath, but if I take the RDS, it's purely open source PostgreSQL, right? 100% compatible, and underneath it's a single database cluster. So if I were to deploy my Postgres engine to a single node, how would it look like? But what we did was, taking that, adding more managed features, right? So the high availability or backups, so and so forth. And the visibility is also more important. So with the PostgreSQL, how do I debug my performance, right? So with the performance insights, CloudWatch metrics, it added all those bells and whistles for the managed service for you, taking away, all of these administration efforts and making it easy and manageable for you. And with Aurora, with respect to Aurora, it's a decoupled architecture underneath. So you have a compute and you have a storage engine underneath, right? And the storage engine is hundreds of thousands of storage nodes you're dealing with. And from Postgres point of view, when you connect, it's not a true distributed database. It's going to be single instance database for you. So all the features you get from Postgres are available, and your application will continue to run to, and the transaction durability is guaranteed as well on Aurora.
Yeah, that I know. I mean, my question would be more like, this solution, it sounds like you are suggesting to your customers, right, would like to have several, let's say, instances of Amazon RDS, and they for some reason need to shard.
Yes, you can take multiple RDS instances, you can scale out your workloads, and also I'm highlighting the fact that the features it currently lacking. So if you are going to go with this approach with respect to open source solutions that are available, it works, but these are all the things you need to keep in mind. You need to have high availability built in. So there is a slide which I talked about. So what you need is basically, you need to use automatic failover mechanism. Sorry. Right? Yeah. So whenever the node goes down, you need to have a physical standby using native streaming replication, and automatically should fail over to physical standby. Say, naturally, if you wanted to build true high availability, for every shard, you need to have its own physical standby. So any shard goes down, you're going to fail over automatically.
Can you cite us on RDS or
Actually, Citus extension is not supported on RDS or Aurora engines. But of course, AC2, EC2, and you can deploy your own Postgres and you can set it up. But at the moment, it does not.
Sorry, I'm still new to Postgres. So when you create a remote table, like foreign table, how do you, what will be the syntax like? Create table, foreign table, table name, and then
Yeah, typically what you do is you create a foreign server, right? You create a foreign server object, and you create a user mapping for that. And then you create a foreign table using this foreign server object.
create a foreign server. How do you mention about
So,
primary and read-only?
oh, I did not put that create foreign. Oh, there is a foreign table. I did not mention create foreign server, it looks like. So the syntax is like a create foreign server, and you give this host name, port name, so and so forth.
But in case of primary goes down and secondary takes over as primary,
What's the host? Interesting question. Good one. So, yeah,
You need to set up a DNS.
DNS.
That can change the names automatically for you. If you are using RDS as an example, it will happen for you automatically. You just do the C name or the DNS will flip for you automatically. But if you are doing this on-premise, the DNS, you need to configure the DNS to have both. If one go down, you have to flip the DNS to the new one. This means that you may need to change anything in your DDL or the schema.
Yeah.
or use the proxy server.
Or the
Yeah, or you can use, no. HA proxy, you can use HA proxy. So with the HA proxy, you can have multiple instances of HA proxy and DNS pointing to HA proxy, and HA proxy will route your connection to,
And use the HA proxy name when you
yeah.
create
So if you go to Patroni code base, it suggests HA proxy. Actually, if you look into the container workload or any, there is HA proxy, a template which you could use to implement.
as a proxy, you need to know the flow of packets. So
Yeah.
anyway, you have to use a similar or DNS configuration for a flow.
So we are out of time. So any questions, please reach out to me. I will be at the booth, right? Thank you. Thank you all.